Hi, my name is Nick Manoogian, and I'm a software engineer at Doppler. I wanted to take a few minutes today to chat with you about SecretOps and why they're such a good fit for cloud development environments. Before we really get started on SecretOps, I want to talk a little bit about applications. Every app is effectively composed of three components. The code, which is the logic of your application, right? We love this stuff. The compute, which is the infrastructure that actually runs our code. These could be like virtual machines or serverless environments, some sort of hybrid of the two, or something completely different. And we've got secrets, which are the configuration for our applications. So these could be sensitive values like API keys that let you authenticate with third-party services. They could be cryptographic keys like SSL private keys, or they could be non-sensitive configuration values, something like a port number or a log level. All of these things are important to running the application: the code, the compute, and the secrets. And I want you to think for a little bit about how much automation you've built around each of these sections. For code, we have really mature processes in place to manage the changes in code, to make sure that it's reviewed and tested. We've got version control systems like Git, and then we've got on top of that systems like GitHub and GitLab, which allow collaborators to review changes to code, run tests automatically, merge them into a number of branches. We can ship the code automatically with CI/CD systems. The processes that we have for managing our application logic, is really mature. We have a lot of workflow around that. Our compute is kind of a similar story. It's a little bit newer that we have that level of automation, but with tools like Pulumi and Terraform, we can manage compute a lot like we manage our code, right? It's pretty rare that someone needs to go in and really click around in the GCP dashboard to scale up their infrastructure or to add new components. Folks these days would much rather interact with an infrastructure as code system to make sure that their state is up to date and to deploy the any updates that they want to make in a much safer way, honestly. And then think about what you've got for secrets, right? The story here is a lot simpler for a lot of teams. Most teams have some mechanism of securing their secrets and making sure that their apps are consuming them in a safe manner, but there's definitely not as much process around this. And those processes are SecretOps. Now, a quick disclaimer, I work for Doppler, and Doppler makes a SecretOps tool. My goal is definitely not to sell you on Doppler. It is to sell you on the concept of SecretOps. There's a number of layers that we'll go through, but they're not really like features that a tool needs to have in order to be called a SecretOps tool. They're categories into which features fit, and it's useful to talk about each layer because providing a name for each of these abstractions really lets you think about how your team is doing. They're sort of like health bars. And you can identify what your health is in each of these sections, and then it's also useful for evaluating a tool. How well does a tool like Doppler perform in this layer? So let's dive right in and talk about some layers. So secret storage. I want to tell a quick story. When I was out of school and I started my first engineering job, I got my laptop and I sat down and I cloned the repo and I fired up the app. It was a Python app, so I did Python space app.py, right, run, and I got an error. It said Google Maps API key missing, right? So I asked my manager. I was like, "Hey, I'm getting this error. Am I missing something?" And my manager said, "Yeah. You got to talk to Steve. Steve will have like a .env file for you. It's got all the config. Just go talk to him." So I ping him. Wait a few minutes. He's a busy guy, and he gives me the env file. Every team's got a Steve, like the guy who's been there for ages and knows everything. So he gives me the env file, and immediately I had some questions, right? Like, do I need to update this? Do I need to edit any of these? Like, are these your secrets that I need to change, or are they my secrets now? Like, one of my tasks was like adding support for SendGrid, which is going to require like a new secret, right? Like, do I put that in the CMV file? Like, how do I tell other engineers that like they need this too? So all these questions were kind of running through my head, and then like let alone where do these secrets need to go when I need to add this SendGrid API key into staging and production, right? Secret storage is more than just, am I storing secrets securely? Like, that's kind of the table stakes. It's about answering the question, where is the secret, right? And what do I need to do to add a new secret into the app? This kind of fits into the concept of sprawl. In local development, secrets are all kind of ending up in the same place, which is on either the developer's local machine or a CDE or some discrete place. But in staging and production or any of your other sort of broader deployment environments, it's not that simple, right? Like you might have some secrets going to this service, some secrets going to this service, and there isn't a single source of truth for where all of these secrets live. It makes it really hard to reason about which apps are using which secrets, and it can create big problems. That's kind of what we're talking about when we're talking about sprawl, is just not really knowing like where your secrets are getting consumed from and not knowing where those single sources of truth are. So I want to show you some screenshots of Doppler to kind of demonstrate what these things look like. But again, these are principles that any SecretOps tool should be able to uphold. So this is what it looks like on the Doppler side of things. I'm looking at the backend project, specifically the development config. So these are all the secrets that are needed to run my app in development. I've got some sensitive values like the credentials for our database. And then I've also got some non-sensitive ones like the port number and the log level. So we can draw those distinctions, which is pretty useful sometimes. And I want to go add a new API key, right? Quick disclaimer, this is not a real API key. It's random hex. You can give it a try if you want, but it's not going to work. So I go add this SendGrid API key, right? And I click save. And now when I go back and look at all of my environments, the expectation is that those same secrets that are in development should have corresponding values in staging and production. And because I've added a secret in development that's missing in staging and production, I'm getting a warning letting me know that I should probably add that value or at least dismiss it and say, no, this is not a required secret in staging and production. That sort of safety is what you get when things are centralized and in one place. So secret storage is really great. The natural next question is who has access to the secrets in these environments, right? I want to make sure that things are locked down. Ultimately, teams need to decide for themselves which secrets should be available to which members of the team. But the SecretOps tool that you pick should be able to enforce whatever policies you have in place. And what's incredibly important is that these are automated, right? You should be able to set up things like roles and groups to enforce the access requirements that you have. You should be able to have some sort of hooks with SAML or SCIM such that when an engineer joins the company, they don't need to go to Steve and get that ENV file. When they join, they should just automatically get access to these secrets. As your team grows, there's only one Steve. He can't dole out ENV files all day. And when they're offboarded, you can easily take an ENV file with you. It's much better if you've got an access gate that you can drop. Not to say that you can't read secrets and leave with them, but it's definitely much easier to drop the gate on Doppler than it would be to have to ask or revoke an ENV file. And then the last section of this is tracking secrets, just like you would your code. So when you're storing, your secrets in an ENV file or something like that, you don't really have this history of changes, which is table stakes in our compute and our code, right? Like you would never, I can't imagine going back to a world where I couldn't see which changes were made by who and when. So I won't show you the roles and groups in Doppler. It's probably what you'd expect, but I will show you what our logs look like. So, over time in Doppler, you can see every change that's been made to your config, who's made the change, what the old and new values are, and you have the ability to roll the change back, right? So you can see I updated the log level from what was previously set to debug. I changed it to warn, and if I accidentally changed the API key or revoked it and I need to roll that back, with one click I can go back to whatever state I was in before. So All of these things are really powerful, but really we're no further than like 1Password, right? And that's exactly what we did at the company that Steve and I worked at. Once I learned a little bit more about how things were working, we kept things in 1Password. We just had our API keys in there. That served as our single source of truth. It was secure storage. We had all of our environments secrets in there. We kept our config somewhere else, but we had it all locked down, and we had it appropriately access controlled, right? Only certain individuals had access to the vault where all of these secrets were. It worked great. But this is the layer where it started to really come apart on us, right? Secrets orchestration is like the CI/CD. It's delivery for secrets, right? And the delivery for secrets was Steve would, when he wanted to add a new secret or make a change, he would go update the 1Password vault, and then he'd SSH into one of the production servers and change the secrets.json file, right? If you forget to update the secrets.json file and you restart your server, it's not going to work. This was quite some time ago. The process there has matured since I was at the company. But still, this is a big problem, right? It's great that you have everything centralized and access controlled, but you also need to deliver these secrets to where they're used. There's a number of ways to manage this. What we do at Doppler is we really try to meet you where you are. So that means we've got integrations to sync secrets to wherever is easiest for you to consume them. So if you find it really easy for whatever reason, your workload is running in AWS, and AWS Secrets Manager is like the preferred place for your apps to consume secrets, then sync secrets into that environment, right? You can use Doppler and sync secrets into AWS Secrets Manager. That has, it's a secure store where your apps can access their information. If you're running in a Kubernetes cluster and the easiest place for you to consume secrets is native secrets in your cluster, sync your secrets there, right? We've got an operator that we provide, and there's other tools that can do this, but sync the secrets from your source of truth into a cluster secret, and then you've got it in an easy way to access those values at runtime. It shouldn't take you months to be able to roll out a system, because that's a really bad story from like a vendor switching perspective, right? And it's also just a huge hassle. One other really cool part of orchestration is automatic redeployment, which is something that we're still investing in at Doppler. But the idea here is ultimately when you change a secret in Doppler, you've got configuration set up to automatically redeploy your workloads to update for that new secret. So the place where we support this right now is if you've got deployments in your cluster and you've got our operator running in your cluster and you've got everything wired up, we can actually restart a pod for you or a deployment for you when a secret is changed. So you click one button in Doppler, you change that log level from debug to warn, and automatically that changes synced into a cluster secret. And then any deployment that is relying on that secret, whether it's mounted as a file or injected as an environment variable, just gets restarted. So this is really where the rubber meets the road. Once you've got orchestration set up, it's really, really easy to reason about where your secrets are going, what's consuming them, how they're getting used. It's a really powerful. This is just a quick graphic of how we think about it at Doppler. You've got your one hub and then many spokes that come off of it. So you can sync secrets to your cluster, like I was mentioning, AWS Secrets Manager, GCP Secret Manager. We're supporting more and more every day. One that's not listed here is actually our CLI. So for developers, which I'll show you a little later, the easiest way to consume secrets is via the CLI. For most devs, they just want to be able to run their app and inject their secrets as environment variables or have them mounted as a temporary file. It's just the easiest way to get at them. So once you've got orchestration set up, it becomes a lot easier to manage the lifecycle of secrets. Steve and I talked about rotating a lot of secrets while I was at this company, and it was just too risky, right? We didn't really have a full handle on which apps were using which secrets. It just seemed too scary or time consuming to have to go through and rotate secrets. But you can imagine if you've got this orchestration system set up, it becomes way easier to rotate a SendGrid API key, right? Like all I have to do is go onto the SendGrid website, go into API keys, generate a new key, put it in Doppler, hit save, wait a few minutes for it to get, restarted. Right now, I know that all my apps are consuming from this mechanism, I know after a few minutes that they're consuming the new secret, and then I can go revoke the old one, right? That's super powerful. But we can actually do better than that. We can actually automate that process, right? If we know that our apps are going to consume new values, we could just set up a rule to automatically rotate secrets on a cadence. So with that automation in place, you've got the confidence to perform these automatic rotations. It would be impossible to do this if you weren't absolutely sure that your apps are connected in this way, right? So this is what it looks like in Doppler. I've set up a SendGrid API key rotation. So I've got Doppler communicating with SendGrid, and it's capable of issuing and revoking API keys that will be then consumed in my application. So this is sort of like the rule that I have set up. And then this is what it looks like on the dashboard. So I've got the ID of that API key, the name of the API key, which is going to be like randomized, and then the secret value. And all of these secrets are alongside my manual static secrets, except for the fact that they can't be modified because they are they're being managed by Doppler. What's also really cool about this is in order to reveal those secrets, you have to click them, which involves an actual API request. So any of the secrets that are masked there aren't really 6 characters long, or however many dots that is. Maybe, 6. It's actually a masked value that we don't even know the length of yet. So in order to reveal the value, I have to click on that, which does an API request, so suffice it to say, you can have a secret that has never been read by a person. That's what's really cool about this, is if you've got automated rotation, the secret that's in the dashboard here has never been viewed by a human, right? It's never been in a human's clipboard. It has never been seen by human eyes. It's never accidentally gotten caught by a screen share or a keylogger. It's only exists in this system, which is pretty cool. You can imagine, one secret's pretty easy enough to rotate, but when you've got hundreds of secrets, this kind of automation is super powerful. So lifecycle is pretty cool. We've got all that tracked. The last layer is observability. And the idea here is that every time a secret comes across the wire, it increases the risk of a leak. Sort of what I was saying before about this has never been seen by a human. Every time a secret is handled by a person or it's handled by a service, that's a risk that the secret's going to end up in an HTTP log, the risk that it's going to get squirreled away to your bug tracking system. It's just the nature of a portable secret. And even though we have risk mitigation in that our life cycle is only 30 days or whatever our rotation cycle is, that's still a period of time where there could be a leak. So observability is about tracking the use and the reads, the fetches of these secrets to answer questions like how which secrets has this person seen, right? Or are there any services still using this API key? It can be also used to find leaks, right? If a secret was leaked and the secret's only being rotated, it's being rotated every 30 days. Well, there's only a handful of services that have fetched this API key. We should be able to track where did this leak come from if this secret was only live for 30 days, right? So this is something that we're still investing a lot in at Doppler, but what we have for right now is something that looks like this. So you can see that I've clicked the password field for the DB. Again, that's a random hex string, but I clicked it, which means that I fetched the value, right? So when I expand this view and I go to look at the reads for this, I can see that Nick Manoogian read that secret from the dashboard. This was the read time, here was the read time, and these are actually versions, so I'm looking at the reads for this version of the secret. So if I was doing an audit and I wanted to go back and say, oh, there was a leak, who could have possibly leaked it? These are the actors, right? These are the services and users that have interacted with the secret at any time. Nobody else could have ever leaked it if they're not in this list. And you can imagine what kind of automation you could build on top of this, which is an area that we're investing very heavily in. So yeah, we're talking about SecretOps here. How does it really fit with CDEs? CDEs end up being an orchestration problem, right? For secrets. I've got these ephemeral environments and I need to deliver secrets to them, right? I need to meet you where you are, right? I need to get those secrets into my environments. Which is why SecretOps is having a healthy orchestration layer is really valuable in setting up CDEs. So in Gitpod specifically, it's really quite easy, almost unintentionally. It was really quite easy to set this up. You authenticate with an API key. So you generate an API key on the Doppler side of things, and you provide this environment variable in your user settings, which effectively connects you and your any workplace that you spin up with Doppler. And then in your workspaces, if you have the Doppler CLI installed, you can run Doppler secrets and fetch them all, or run Doppler run to inject the secrets into your app as environment variables. It's kind of really just that easy. We also have somewhat newer support for a VS Code extension, which has a couple of secrets management features, like you can go in and modify secrets in the environments that you have access to, which is handy. You can also there's this hover functionality. So if you're writing in a handful of languages, you can do process.env is the JavaScript way of loading environment variables, right? So it'll autocomplete by fetching the secret names from Doppler that are available to you. So it's helpful for exploring code, which is kind of handy. And then you can also hover over values to get the actual underlying secret value. So in this case, I'm hovering over the SendGrid API key, and I'm getting that actual value back as a hover prompt. Is a little bit more useful if you're reading static configuration variables. Like I'm looking around in the code and I see like enable underscore analytics in the code. There's an if underscore analytics is enabled is true, then do this. Well, I can hover over that value and say, oh yeah, it is true, so I should be running that. If not, I can go into my panel and enable it. So this is really where I think there's a lot of value in a SecretOps tool, because if secrets are in your way, it's a problem, right? Your developers are going to work around it. But if they're not in the way and they're useful and they're easy to access, then they're part of the workflow, right? Last thing I want to talk about are two trends that I'm really excited about and we're investing in heavily at Doppler that are sort of on the horizon for SecretOps. The first is identity auth. The most popular protocol here is OIDC, and it effectively allows workloads to authenticate using their identity over a portable credential. So what we mean here is, a couple slides back, I had you put a static key right in your variables, and that is a token that can be used to authenticate with Doppler. That's a really important value, and it should be rotated. It has a life cycle like any other static secret. So a better way to do this, which is something that we're working on with Gitpod, is allowing the inside your workload in Gitpod here. This workload would be able to, through our CLI, sort of prove to Doppler that the request is coming from your user in Gitpod. And then on the Doppler side of things, you can set up a policy to say, anytime a Gitpod user is talking to our service, then make sure that it gets associated with this user on their end. So this effectively eliminates the zeroth secret problem, which is that in order to access your secrets in Doppler, you need a token, right? It eliminates that problem. So really excited about this. It really closes the loop on having a completely lifecycle free or lifecycle managed secrets environment. And the second thing is dynamic secrets. So rotation is handy because you're changing, you're effectively like you're fixing the life cycle of the secret to 30 days, right? But for those 30 days, that secret is available to whatever services have access to it. For dynamic secrets, the story is a little bit different. Secrets, instead of being rotated, don't exist until they're requested, right? So when your application wants to get a secret, it would make a request to Doppler, and then alongside all of the static and rotated secrets, it gets back a dynamic secret, which is issued right then and there, right? So the one we have support for right now are AWS IAM users. Suppose that your CI system or your build system needs to have a AWS user to perform this deploy. Well, instead of having one always available, when that CI job runs, it makes a request to Doppler, and we issue you a brand new user, AWS user, and a key to go along with it with whatever policy you specify. And then for the duration of that job, you have access to this user. And at the end of the job, or until a fixed amount of time passes, at the end of that, it will get automatically revoked by Doppler. So that means that this key was only alive for this small period of time. And because there are new keys every time, each workload or user only has access to one key. So if for whatever reason a secret was leaked, right, you'd be able to easily trace that back to the exact workload that had access to that secret at that time. It's a really, really powerful way to manage secrets. Not a lot of folks are using this yet, but it's something that we're particularly excited about. You made it to the end. Thank you so much. My name is Nick Manoogian. We're really excited about SecretOps at Doppler. If you are too and you want to chat more about it, please feel free to drop me a line, nick@doppler.com. And I hope to get your feedback. Again, thank you for watching, and hope to see y'all soon.